Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
This is the Web Platform Podcast, episode number 194, Off the Main Thread with Surma. I'm your host this week, Danny Blue, and with me as always is Eric Isaacson.
Hey, what's up?
How's it going, Eric? How's your week? How's your week been?
It's been really busy. We're testing some things in beta, so there's a lot of code freeze. So we're going to get busier after the code freeze.
Yeah, I feel like I feel like whenever we enter a new season, everybody says like, oh, this is when things really get busy. But it feels like that's every single season. So I guess it's just depending on exactly which part.
We have a few days during the year.
Yeah, well, I mean, as soon as we hit November, everybody's on vacation pretty much for the rest of the year. You almost can't really plan on getting a whole lot done at the end. But that is not what we're here to talk about this week. This week we are here to talk about just things running off the main thread, specifically with the web. And we have a very special guest on to talk to us. Everybody, welcome back, Surma.
Whoop. Thanks for having me.
Yay!
Of course. So for those that may not be familiar with you, why don't you give us a little bit of background, who you are, what you do, what you like?
Of course. I work as a developer advocate for the open web at Google. So I work with the Chrome team, but also, we love all browsers equally, at least on the web DevRel team. And I have, for a long time now, been looking at off-main thread architectures in the sense that JavaScript is single-threaded and most other platforms have a way to run things on a different thread. And I always wondered why the web doesn't. But only really for a year now has it been my official label that is my topic that I want to work on and that way I want to actually put my energy in to bring the web forward. And so that's what my work has been consisting of.
Yeah, I feel like it's one of those topics when you look it up on Google, you're like, I know I want to do extra performance for the main thread because when you see the Lighthouse performance, it says, oh, well, you could optimize this by, putting stuff off the main thread, but it doesn't really tell you much, right? There's like an article, I think. And so like to look for actual code examples or real experiments and things like that, it's kind of hard.
It's super, I almost want to say underdeveloped, in the sense that we really just now are reaching the point where I think everybody's on the same page that we are actually doing apps on the web and not just documents anymore. So for the longest time, we've been living on this web as a document platform that had a couple of links and a bit of Ajax, maybe, and all of that really didn't necessitate multi-threading. You had one pass of layout at the start when the document was loading, and at that point, network was the bottleneck, not the layout performance. So the main thread wasn't really overly busy; it just did its thing, put the screen on page, and then the user would start reading that document. And now we're getting more and more into the territory where we actually have an app. We have views, we have transitions, we have gestures, we have images, dynamic content, and over the years, browsers have kind of evolved in their internal architecture because if you remember back in the day, the entire browser only had one thread. But if you had tabs, was blocking, your entire browser was just frozen. And since then, browsers have adopted like a multi-threaded paradigm that each tab nowadays has its own thread. But within that page, you're bound to that one thread pretty much, and it does everything. It parses your document, it executes your JavaScript, it does the layout, it does painting, and then it actually parses CSS and colors in the boxes, and then does compositing to arrange it all to the image you see on screen. It, processes user interactions. That's a lot of work. It really is a lot of work. And we just keep adding things with frameworks and with animation libraries and with, I don't know what you want to do, like audio processing maybe. So we have really chucked more and more and more at the main thread. And so the goal to move stuff off the main thread kind of makes sense, but there is no ecosystem around this. And that's what you say, like, Lighthouse is like, hey, your main thread is really busy. Maybe you should do something about it, but also just figure it out yourself. because we actually don't know what to do here. And so I've noticed that recently people get more and more aware of the problem. It's kind of starting to become a topic. Like, hey, since IE10, we have had workers, and they're kind of solution, but they're not great to use. And so that's kind of where my work begins, really.
Yeah, I remember I read an article David East had written about Firestore and how he was using a Webpack, and by using web workers, he was able to get his main bundle down by like 95%, but still maintain all those features. So I'm surprised over the past year it hasn't picked up and gotten more focus.
Well, the ergonomics haven't really gotten any better. Is overall one of the issues, especially when using frameworks.
And I think there's like 3 facets to actually what you all just touched on. So the first thing is the ergonomics of a raw web worker they're actually not bad, but they're really unorthodox for what most people are used to when it comes to threading. So if you look at Java, C#, C++, usually you create a thread and just say, here's a function, run this function, and then the thread says, I'm done, and things happened in the meantime. Great. In JavaScript, that isn't possible because JavaScript has been designed as the single-threaded language. And so you can't really just run a function on a different thread because memory sharing is not a thing. So yeah, like all the data structures in JavaScript, especially the DOM and other things, are not designed to be thread safe. And so you will never have concurrent access to the same variable from threads in Java because that would just break everything. There have been some proposals actually to kind of add that, but these are all very invasive and haven't progressed. So at least at the current point in time, that is not an option. One way to actually make workers kind of make sense is to look a couple of decades back, actually, at the actor model, which thinks about concurrency in isolated single-threaded entities that communicate by sending messages. And that's exactly what workers can do. If you create a worker, you can send messages to the worker, and the worker can send messages back. And so there's this whole model on how you architect web apps architect apps with that model. And now you can transfer to the web. But it will still feel weird for a while until you get used to that model. So that's, I think, one of the hurdles why workers themselves were never really successful, even though they have been around since IE10. And that's where one of my projects comes in, which is called Comlink, which kind of abstracts away that weird interface of workers and kind of gives you back the notion of just sharing values between threads. Now, obviously, I have to cheat a little bit, and it only just looks like you're sharing them, but it works. So what you can do is you can create a worker, you can create functions and classes and whatnot in the worker, and tell Comlink to expose these values to the main thread. And then you have these values, then you have variables on the main thread as if they were local variables, but they're actually being stored and processed and executed on the worker side, and there's some message passing magic happening under the hood. And I personally find that to be a model that actually makes workers quite enjoyable and quite easy to use. And then the third bit I want to touch on that you just mentioned is that frameworks currently have a very interesting role in web development, in the sense that each framework always expects to be the center of the universe of your web app. When you write an app, you start with React at the bottom, and then you build components. And if you want to use something like IDB or a hidden API, it probably becomes a component within that UI framework. The UI framework is the puppet master of your web app. And I think that's actually the point where, again, it's hard to integrate workers, because if the component is the basic unit of authoring, which is involved in rendering, and rendering is synchronous, then working with workers becomes really, really hard, because the communication with workers is inherently asynchronous. So moving components to a worker doesn't really make sense, but I think we can avoid the whole problem if we try to not make the UI framework the center of the universe, but just one participant in our app. And that's what I've been actually trying to do in one of the latest blog posts, I think, where I talk about, you take a React app and you use a state store like Redux. And the nice thing about Redux is that it's completely independent of UI APIs. It doesn't need the DOM. It doesn't need any other APIs. It's literally just pure data objects and manipulation of that data object. And so Redux actually runs well in a worker. And then we can literally just throw comlink at it, and suddenly Redux runs in a worker, and all the UI stuff runs on the main thread, and we have moved out of work away from the main thread, giving the main thread more room to breathe. That actually has many, many implications, which I'm not sure we can get into in the whole thing, but that's the core concept that really I'm trying to work out on how we can move everything that doesn't need to run on the main thread to a different thread. And there's many different facets to this, but that's basically what I'm looking at, where comlink is probably one of the biggest puzzle pieces here.
So I have a question about that specifically, and this is specifically about the underlying workers, because I know that it's been quite a few years ago. I tried playing around with something similar where it's just a very simple Redux implementation, but it used workers as the store. One thing that I could never quite figure.
Oh no, he was about to say the problem, and then he disconnected.
It's like the worst point.
Gods.
Well, when he comes back, we can touch on that. Something we glossed over, though, to move on a little bit, is so the main thread. We've been talking about it like we know exactly what it is, but there may be some people listening who don't know what the main thread is or threads in general. Can you kind of go through that, just the basics?
Yeah, that's a good point. So as I said, like each tab in your browser has one thread. That's technically not true. There's technically more under the hood, but conceptually you have one thread because JavaScript is single-threaded and doesn't have thread safety, and so it needs to be integrated with all the APIs like DOM in this single-thread environment. Now the problem with that is that it has to do literally all the work that comes up when you try to bring a website onto your screen. And there's a lot involved here. So if you download an HTML file, that needs to get parsed. And then the subsequent resources need to get downloaded and parsed as well. Then probably some JavaScript is in there that needs to get executed. The styles need to be calculated and applied to all the different DOM elements. Then as I said, the coloring in needs to happen. So when I set a background color on a div, the browser needs to figure out what size is the div, where is it on screen, and which color do I need to fill it in with. And all these individual steps are work that needs to be done, and that is work that the main thread needs to do. And when you load a website, it's not that big a deal, and that's why I said, like, in the era of documents, nobody really thought about this problem, because you load the page and you didn't really, you saw it like progressively building up. And that was just kind of part of the experience, and you didn't mind if it took a second, maybe 2 seconds, maybe a bit longer. But we are now in the era of apps where you actually have animations running, and you want to have smooth gestures where when you zoom in, you want to feel like the image sticks to your finger while you do that. And so for the smoothness to happen, you need to animate at roughly 60 frames a second. But most importantly, you need to have a steady frame rate, because that's how psychology has found out that that's how you actually make it feel smooth. You need to be at least at 60, and it needs to be a consistent frame rate. Now, the implication of that is that you have about 16 milliseconds per frame to do all the work you need to do to generate the next image to put on screen for 60 frames a second. And now every frame, the browser has to do or the main thread has to do all the work I just listed, plus your JavaScript. And that is a lot to cram into 60 milliseconds. And now we are talking about iPad Pros have 120 hertz. So you only have 8 milliseconds. And now we also are seeing that in, for example, India, feature phones are making a massive comeback, in the sense that very, very cheap phones, like $15 cheap, are available to the masses, but with a modern browser, like actually modern, recent version of it, means they can browse the full web. So on the one hand, we have devices where the frame rate is rising and your budget is getting smaller of what you can do in a single frame. On the other side, we see that slower and slower devices are coming out that have weak hardware. And so what takes half a millisecond on a modern phone might take 4 milliseconds on one of these feature phones. And so we're getting this super wide spectrum of devices, and your piece, basically the JavaScript you write, is completely unpredictable in how long it will take to actually run. And so this guarantee of getting a smooth frame rate to make the interactions feel good is going to be harder and harder to keep if we cram everything on this main thread. And yeah.
And Danny just came back too. I know
Hi,
he was about
sorry.
to ask a question. It was very, very tense. He's about to
You wanted
say
to
it, and
ask something
bam,
about
got
you
knocked
had
out.
an experiment with Redux
Yes.
and workers, and then you just
Yeah, so I'm on my work laptop and I'm connected to like 2 different VPNs, and both of them disconnected, which meant that so I could still see and hear you all, but everything else just ground. It's fine. But yes, so I did an experiment quite a while ago when I first started playing around with web workers because of the message passing thing. It was the same thing. It's like, oh, well, this is like like Redux or CQRS or some other sort of message queue system. I can do that. I'm just limited in what I can send to and from. So I did the very similar thing. I was like, well, I can set up an entire Redux store and just handle different situations and just post the result back. What I was concerned about, and at the time couldn't find any good answers on, was the lifespan of a web worker, and if it was safe to actually store potentially long-term data in a separate thread. And I was curious if you have it, since we're just talking about doing something like that, if you have thoughts on, it's like, yes, it's absolutely safe to keep it over there. Did you always like keep the state on the main thread and you always pass the whole thing back and forth to do the all your stuff? So I'm just very curious about that.
So at the spec level, the worker keeps existing until you tell it that it can stop existing or the entire page gets unloaded. So it is a completely separate thread JavaScript scope. Basically, if people haven't worked with workers that are listening, you can imagine it like starting node twice. One node instance is your main thread, the other node instance is the worker, and you can send messages. And it will keep existing. So I have not, at least not for that reason, I've never replicated my state to the main thread. I kept it all in the worker. I did sometimes store it to IndexedDB if I wanted to persist it across reloads, because the worker and the main thread share the IndexedDB database for the origin. So if the worker puts something in, you can pull it back out on the main thread if you wanted to do that. That works. That being said, there is a bug in Safari, which we have encountered in that, and I think that is an optimization from them that so far they have gotten away with, because barely anyone uses workers, let alone long-running workers, in that a worker will sometimes just get killed. Or I think actually in this case, it might only be affecting if you use comlink. So comlink uses proxies under the hood to basically pretend that there's an object on the main thread. It's not actually on the main thread. And my hunch is, I might be wrong here, is that their garbage collection counting goes wrong when there's proxy involved. I think Safari thinks nobody is holding a reference to the worker when in fact comlink is. So we had to find basically what we did in prox, where we make use of this exact pattern that is state runs in the worker and the renderer, the UI, runs on the main thread. We just put the worker instance on the global. Don't kill me. But yeah, on a conceptual level, you can just, the worker is long running and will not go away until you call terminate on it.
Yeah,
Cool.
and
That's good to know.
Yeah, absolutely. You have a blog post on that too, where you talk about that. I think there's 3 of them total that you had with web workers.
Yes, I did a mini series. Basically, I started with the whole motivation behind it, like, because I often hear people ask the question, like, when should I be using web workers? I don't have any big number crunching task, and that's often how they're perceived, as like this thing that you use when you have long number crunching that will block the main thread. Like, for often I hear the example, if you want to render the Mandelbrot fractal onto a canvas, there's a lot of looping calculations involved, and that would block the main thread for too long, and so you put it in a worker. And people kept asking, like, when should I be using web workers? I only have a normal app. And basically what I'm saying is always, you should always be using web workers for the simple reason that the exact same pattern exists on both Android and iOS, that you always use off-thread programming or off-thread routines. And the mantra that I'm really going after is the main thread should actually be called UI thread. The name main thread is pretty stupid. I mean, I know where it comes from, but nowadays it's like, it sounds like main road, and it really shouldn't be used as the main road. It should be used as lightly as possible. And the reason for this, exactly as I just explained, is that we are living in this era where we get faster and faster devices, but also slower and slower devices. So the spectrum is getting wider, and the amount of time your code takes becomes more and more unpredictable. So what might be working on a phone today might not be working on a phone tomorrow, or at least not run fast enough. So you want to run as little code as possible on your main thread to make sure that you reach as many devices as possible with the performance goals that you set yourself. And so anything that is, the main thread itself should actually be called, in my opinion, the UI thread. And so that kind of then makes clear the mantra that I'm going for, which is UI thread for UI work only. Only if your code is touching the UI, that is the DOM, the styles, anything related to that, then you have all the reasons to run off the UI thread. But if you don't, that code should be going somewhere else. And that in itself is obviously just a mantra that doesn't really go into details on how to solve this, but that's why I've been working on stuff like Comlink to show people that it actually can be doable, maybe even convenient. And then there's obviously benefits when you actually embrace this good enough. As I said, your main thread will be very free, so you will always be able to interact with the page. You will never have this frozen state where you sometimes can't even scroll, or you can't zoom in, or you can't click a button and the hamburger bar doesn't open, whatever. But also another side effect is, and you hit on that earlier, Eric, is that you are distributing loading and parsing costs. If I put my Redux store in a worker, I don't need to parse the Redux code on the main thread. And so therefore my main thread will be spun up faster. Like, it won't download faster because it's still the same network connection, but one parsing happens on the one thread, the other parsing happens on the other thread, and the main thread needs less code to actually get up and running. And that's one of the biggest problems we currently see, that a lot of people ship these big monolithic bundles of JavaScript to the main thread for their app, and it takes up to, 8-9 seconds for this to get parsed and run on the main thread until the app can actually boot. I should probably say one thing, which is kind of sounds a bit weird, but off main thread architecture really isn't about making your app faster. If everything goes right, it will be just as fast as before, because you're still doing the same amount of work, just part of the work happens on a different thread. The really upside here is that your main thread will always stay responsive no matter what device you run on. Because in a worker, you can block. If you block a worker, nobody cares. The main thread can keep firing events and can parse user input, and you can scroll. So it will feel the app is still responsive, and that is good. And that's really what I'm after, and that I want to help developers reach as many devices as possible, the low-end devices to the super high-end fast frame rate devices, without having to test on all of them, because it's so unpredictable how much your code will take. In a worker, it's not nearly as relevant anymore how long your code will take, because the main thread can just keep running as it is.
That's a fair point too, because I always think of it as performance. Like, because you look in Lighthouse and there's like that specific thing, hey, all your stuff is taking too long, just put it off the main thread, right? So, that's been a push here, is getting performance down for large applications. A lot of times people will post blog posts, and like those blog posts will talk about apps that have, a dozen pages, 24 pages, but at scale, a lot of this stuff is very hard to manage. So
yeah.
it's a good point.
The reason I bring it up is,
go ahead.
Yeah, the reason I brought it up is because I heard, I've seen a couple of experiments from framework authors who were trying to evaluate workers, because some people are quite passionate about workers being used and ask frameworks to support workers. And I can't blame them, because, as I said, like, frameworks are the puppet masters, the center of the universe when you write a web app. And so, of course, if you framework doesn't have nice support for it, it can be kind of hard to use them. And a lot of frameworks have actually looked at them and often came back with a result, didn't really give us any benefits because it didn't make your app faster, or it was hard because you don't have access to the DOM in a worker. Those are the two main arguments I hear. And I was like, yeah, you don't have access to the DOM in a worker, that's true, but you shouldn't be moving UI work to the worker because that belongs on the UI thread. And yes, it won't make your app faster, but it will make sure it will never be slower on any of the other devices. So it's really about reducing risk. And I think that's something that I really need to talk more about, because there's still, people think about performance almost exclusively in making things faster or taking the fastest choice. But I think there is something to be said about also reducing risk of things getting slower without you knowing about it. And that's probably what this is more about.
That's a harder thing to wrap your head around too, I think, as a developer.
Yeah.
Well, perceived performance is also, like you were saying, like that's what I've always heard that type of thing referred to, is that technically you could have something that is faster, but if that, so say something takes 4 seconds, but it blocks the main thread while it does it. And then you have something, and like everything locks up, you can't scroll, you can't do anything. And you have something else that takes an additional second, but like for it to be complete, but the UI thread doesn't get locked up. Like you said, the perceived performance is better, even if the other solution is technically faster. And probably some of the examples of things that you all have done, some of the more extreme examples like Squoosh are probably, I mean, well, there are other things about Squoosh, but if you were doing like something that computationally heavy entirely on the main thread, there's a chance it could be faster, but it would definitely be worse.
Exactly. So, I mean, Squoosh, I've always considered like one of the slam dunk use cases for workers, because encoding an image, especially if it's user provided and you don't know the dimensions, there's no way you can actually predict how long it's going to take. So that needs to run in a worker. There's actually something that you mentioned. It's really interesting to bring this up. In Prox, the Minesweeper clone we wrote as a PWA, we had this very exact revelation in a way. So we have, if you imagine a Minesweeper field and you click somewhere, it needs to get calculated which fields are now revealed. If you click in an empty field, you get this whole ripple effect, both in the classic Minesweeper, but also in Prox, and where you click somewhere and then the whole field gets revealed. Now on feature phones and super slow devices, even calculating the fields that need to get revealed can take quite a while. And so I took Prox and actually backported everything back to the main thread to make a comparison, which was super interesting, because it then turned out that if I tap a field, the entire app is locked for 6 seconds to figure out which fields need to get revealed, and then suddenly the result snaps into view. In Prox, what we're doing is we're basically starting the algorithm to traverse through the entire state grid and mark the fields that get revealed. And when we have a couple, we send that over while the algorithm still keeps going, so we can update the UI as the algorithm goes along, which gives this really nice outwards growing reveal effect. Now, the fun fact is that start to end, this reveal, sending intermediate results and revealing animation almost, takes 12 seconds, so twice as long, but it is 100% better than the alternative. And so in this kind of territory, slower doesn't always mean it's worse. And that's something I think is really interesting, and where I will always, it's one of the first things I think about when someone does micro benchmarking. We're like, yes, your loop is 100 milliseconds faster than the array for each. But what is the trade-off here? Because it's not only just speed, it's often readability, edge conditions, or perceived performance / user experience. And all these things need to be considered whenever you do any kind of performance work.
Yeah, too. When we're measuring performance here too, like we'll change one thing, and one of the measurements will get a little better, and then another one will go up. So it's even trying to hit those small pieces. It doesn't make as much sense as kind of looking at it as a holistic thing, like you're saying, user experience. Look at everything. Absolutely. Just to play devil's advocate here too. So like web workers are one implementation of doing these threads. So there's other things that are not threads per se, but could achieve some of this, maybe. I don't know, you tell me. So like web sockets or WebRTC with the peer-to-peer. Are these things that make sense for this type of work, or does it have other use cases?
I mean, neither WebRTC nor WebSockets will really give you anything in a purely client-side scenario. That's always moving stuff to the server side, right? Or to a different device in the WebRTC case. And that can have legit use cases. So fun fact that Comlink actually does work with WebRTC. I built a demo a while ago where you type console log in one browser and it appears in the console of the other browser, which I always thought was fun. There's definitely use cases for moving work to the server side. There's especially a use case if you think about progressive enhancements. If a device is not capable of a certain technology or just not powerful enough, that could make sense. But that is, of course, a bigger ask in terms of infrastructure, development time, privacy. It opens up many more doors that need to be considered. So, for example, with Squoosh, we wanted to make really sure that we do it all client-side, because otherwise we're uploading images from our user to a server. And that is a whole privacy door we did not want to open. So we made sure that Squoosh never sends anything to anyone. It all stays on your device. We don't even store it locally. It's literally just in process memory. And that was good enough reason for us to actually make the whole thing work.
Excellent. I mean, I was thinking too, like with your implementation with Redux and how you did Comlink in there. I really liked it a lot. I think it was a small abstraction on top of things. So because web workers can be a little intimidating to work with. But I was thinking, oh wow, well, what if I needed to synchronize data between a worker and a node server? So to be fair, web workers are web APIs, right? They're not part of JavaScript, the language proper. And so when you go into Node, there used to be a module like Node Worker or something that allowed you to do something like this. But how do you recommend handling that if you need to synchronize data into a server as well?
I mean, if you want to synchronize data from a worker to a server side, you don't do it any differently than you do on your main thread. You use a fetch or whatever it is, or WebSockets or whatever it is that you want to use.
Okay.
That doesn't really change. And luckily, fetch and most of these APIs are available in workers, because I don't think I've mentioned, but some APIs are not available. So for example, Web Bluetooth, I think, for example, is currently not available in a worker, or like WebRTC.
Yeah, I would imagine too.
Yeah. In terms of Node, since Node 11, I want to say, maybe, or maybe even Node 11, I think. There is workers now in Node in the core library. They're ever so slightly different. So I wrote a tiny little extra module in Comlink, so you can use Comlink in Node as well. But we have workers now, so you can use the same paradigm, the same mental model that if you already know workers from the web, you can also now use it in Node.
Yeah, I think they were made production ready in version 12, but they were definitely in that before that. But yeah, that's pretty awesome. I've been thinking about playing around with those. I didn't know if you had an implementation of that.
I have an adapter. It's not 100% correct, as I've just learned. Someone opened an issue, so I need to fix that. And there's also still the plan that I have where I want to write another adapter that you can use Comlink over WebSockets or something, because then basically what you could do. Yeah. So Comlink in itself is really just an RPC library, remote procedure call. And it doesn't actually really matter over what medium you transfer the messages. It was written specifically for workers and main thread and their post message protocol. But as I said, I already wrote something that made it work with WebRTC, which is also just message sending, but slightly differently. And the same could actually work for WebSockets. So what that means is that you could have classes, values, whatever, on the server side and use them from the client side if they were local. And that could be interesting. I imagine some gaming architectures could benefit from that, just having basically the server-side state class available with methods and everything that's on it quite easily. So that's definitely something I want to explore in the future as well.
And how would you go about debugging like using web workers in general? Because I noticed on the performance tab, I think it'll show you the different threads on there, right? But I mean, how do you kind of drill into that and look at that? Or
I
other
mean,
tools?
you do it like any professional. Use console log. No, seriously, it's not the greatest debugging story in the sense that it is not as easy to follow messages being sent as it could be. We have, at least in Chrome DevTools, it's gotten better in the sense that if you basically step through your code and you encounter the post message call, which sends a message to the worker, you can step into that post message call and come out on the other side, and now you're debugging the worker. And if that sends something back, you're back on the main thread. That is kind of cool, but the second you have an abstraction like comlink over that, it gets more iffy. But you can use normal step debugging on both sides. So usually what I do is like I set breakpoints on my main thread code, I set breakpoints on my worker side code, and just wait for one of those to get triggered. And then you are pretty much in your normal workflow. The only thing to keep in mind is really that just because you're debugging your worker doesn't mean that your main thread is paused as well, because that one will keep running. And vice versa, if you're pausing your main thread, your worker will keep running, which is the whole point. So we are now in truly parallel programming here, which everybody who's done it knows can be very confusing and very interesting bugs can happen. The only thing we don't have is shared memory, which absolves us from some of the problems. I am working with DevTools team to come up with something good, but nothing that's even close to worth talking about. But I'm thinking about things like it would be nice to be able to basically intercept a message before it gets dispatched to a worker and potentially manipulate it. Similar, basically, I also want to look at the Redux dev tools and get inspiration from them, because effectively that's what they are. They just get messages, just they call them actions, and just see those listed. Have a log of the messages that you can still inspect and see what was in there. All these little things would be probably, I think, quite helpful for debugging workers.
So I know this used to be an interesting case that I've run into before using workers is, and I don't remember if there are any limitations to this or not, but so I guess I'll just put it in two parts. Can web workers themselves spawn other web workers? And if so, do those child workers have additional limitations that the initial web worker do not have?
So nested web workers are a thing. I will now look them up because I know that Chrome has them. I'm not sure. Oh, can I use this and list them? Nested web workers.
Damn, you stumped them.
I can't seem to look them up like in other browsers. So they are a thing. Chrome has them. As far as I know, they don't have any other limitations. It's practically as if you spun up a second worker from the main thread, and then just passed a message port to the two things they can talk directly. So I don't think there would be any limitations. I'm not sure if any other browsers ever followed through on nested web workers, and I personally haven't yet needed them, to be honest.
But I haven't either. I just remember when I first started looking into them, I was like, oh man, because I was thinking about analytics, right? It's like, okay, you could pass a big blob of data to one worker, which could then do the work to figure out, well, it's like, okay, well, it's this type of data, so I need to get these 3 different results back from it. I will spin up my own worker so that all of that work can be done over there in parallel rather than serially. But yes, so I've also not really run into a situation where I'm like, yes, I need that to get something done, but they sound interesting and sound like a great way to crash your computer.
Yeah.
Yes, do recommend.
I looked briefly at like different types of abstractions around web workers, like Workway and Workerize, which you mentioned in one of the blog posts. I didn't get a chance to really go through it. Like, what are the kind of different approaches people are taking to wrap this?
You mean for state management?
Well, I think I didn't look through Workway or Workerize. I just kind of briefly looked at the README. I didn't scan any of the code though, or look at that.
You mean Yes. So sorry, I heard the names and thought of completely different projects. So Workway is Andrea Giamacci's / Web Reflections project, which does a very similar thing to what I do, and Workerize is Jason Miller's older project that also does this in a separate way, if I remember correctly. It's all very close. There's a couple of differences in between. Some of them are more explicit. Some of them have older browser supported. Some of them don't. I think Workerize, if I remember correctly, is limited to functions because he chose a different way. He doesn't actually do the RPC. I think he just sends strings. Like he stringifies the function, sends it over, evals, and executes it. So that is actually something that I wrote as well called Clooney, which I wrote on top of Comlink, which allows you to not have to worry about the separate file issue. Because with workers, you always have to write a separate file that you pass into the worker. By stringifying that function, that kind of disappears, but has other weird side effects because you write a function and you're kind of used to using variables from the outer scope, but now that won't work anymore because you're literally just stringifying the function. So that's not. It can be a really nice pattern, but it's not. It has tripwires.
If you can use the blob API and create the string, and then you create your blob array, and then you just say that this is of type JavaScript, and then you can send it over. And then you almost have to treat it like PHP functions. So like anybody that's on PHP, you have to explicitly pass in variables that you want to use within a closure. And you can kind of write something over top of it to use it that way so that you can pass other things in explicitly. But like it's a little bit, it feels like you're doing something you're not supposed to.
Yeah, it's definitely not something that feels very idiomatic in JavaScript. And the other side of blob URLs is that they don't have the same origin. So relative paths will not work. If you like fetch something with a relative path from within there, it's just going to not find it. And that's bad. And so I actually tried to write a proposal for adding a new type of function to JavaScript that would make them transferable without losing all the semantics. But it didn't go anywhere. I'm now trying to figure out what a better proposal is less, because my proposal was admittedly very invasive. Not lots of new things, but new syntax for something that's only a very small change in semantics. It didn't quite add up. So I did definitely listen to the feedback. I'm just still working on figuring out what the alternative will look like. And that's what I mean. It's JavaScript is really, it is a language, and as any language, it has idioms. And threading is just an idiom that is, at least threading how we all know from the other languages, doesn't fit in there. And so I think there's idioms that do fit. Like I said, the actor model, or Comlink, which is actually similar to the actor model, more like Pony, another programming language, has modeled it. But the classic, I want threads and mutexes and just run a function on a different thread, those kind of semantics just don't work well with JavaScript and the idioms that it promotes. And I think resolving that kind of dissonance is really what we need to make workers more popular. And so that's what I'm working. That's the whole work I'm focusing on.
Well, also too, I was thinking, like you said, kind of the frameworks kind of run what we do, where you start off, right? And when you approached this blog post, correct me if I'm wrong here, you looked at Redux, you looked at the interface for that, and you basically did the same interface so that it would be totally compatible with Redux. So if you did that with something like MobX, which uses observables, would that be any different, even though it doesn't use promises per se?
Observables are really interesting because they're obviously inherently async. You kind of await the next value to come from observable, right?
Yeah.
And I think that is therefore actually a better fit, because the observables are already inherently async. And so matching that to a post message pattern under the hood is really not a problem. Actually, what's like that, I actually think streams are a really good way to model observables with platform primitives. It's not a perfect fit, but you can make it work. And since a while ago, at least Chrome has transferable streams. So that means that you can write a stream in a worker and post message it over, but the code for the stream will keep running in the worker, but the values come out on the main thread. And so you now have an observable that has kind of the crossing over the boundary from a worker to main thread just built in for free. And so I think that's a pattern that I want to explore some more. I wrote a library a while ago that builds observables with streams. So all the standard patterns you have, like a filter and a map and all these things you need for observables. But now you could basically run the filter and the map in a worker and have that processing happen off main thread because it's probably not UI related. And then at the end, you go back to the main thread and pump the resulting value back to your UI framework to update your UI. And so that's really the pattern that would be my utopia. I think we're quite a bit away from that, especially because streams themselves are not even implemented in most projects, let alone transferable streams. But if you want me to imagine the future, that's what I would do. And on that note, I mean, I think many people there's a lot of fans of RxJS, which is, if I understand correctly, just the JavaScript implementation of ReactiveX. And ReactiveX has many implementations for other platforms, like, for example, Kotlin. And what I find really interesting in the Kotlin implementation is that you basically just write down your observable path. So you have observables. You have the source and a couple of maps, a couple of filters. Maybe you merge a couple of observables. And at any point, you can just say this part of this pipeline, run it in a different thread. And it just works like that. And so that's really what I want to see on the platform, but that's going to be a while. But I think that's the role model we should look up to.
Yeah, I'm surprised how much faster things are coming out, though. Like, I was just listening to a podcast with Jen Simmons from Mozilla, and she was talking about how they were working on the aspect ratio in CSS. And just the way she explained it was very simple. Like, okay, well, we're already using width and height, and then you have to set your image to height auto in the CSS. And that takes care of it. You don't have to have an extra thing on there. So going backwards compatible. I think things are moving much faster, I guess is my point, and much more in a uniform way across browsers.
I think since the standards bodies have put much more value on low-level primitives that compose well, that is a big part of the reason why we can iterate so much faster, because most of the low-level primitives are small, self-contained, easy to reason about, easy to get right. And then we have user libraries that build on top and turn them into powerful features. But now at some point, we even reach the line where standard bodies build on top of these primitives and can ship new things with that. And so, yeah, I think the pace is just picking up, and it's the result of a lot of hard work from the people in the standards bodies.
Yeah. There's also, we didn't get to go through testing workers. That could be a whole episode in itself, I'm sure. But like, I noticed in one of your blog posts, you talked about how you wrote a roll-up plugin so that you can take an app, right, and just run with it and roll up, and that works great with Comlink. And Sean Larkin had told you Webpack 5 will have support for workers, because right now Webpack kind of sucks with workers. So I don't know, like, if there's an update to that story or.
So Webpack. The problem with Webpack is, like, it does work with workers in a way. Jason Miller wrote a plugin for it.
Yep.
And that actually works great. Like, you can just write ES6 modules in both main thread and worker land, and it just works. The problem that Webpack has is that if you have a shared dependency, so for example, if you use Comlink, you would use Comlink both on the main thread, you would import it on the main thread, and you would import it in a worker because you need it on both sides. When you use Webpack, that means you would have to download the file twice, because Webpack can't use the same module format for the main thread as it uses for workers. And that's kind of sad. So you would double download. If it's only Comlink, which is like a kilobyte, not that big a deal. But the more shared dependencies you have, the more the double downloading will actually hurt your user. With Rollup, that doesn't happen. It can actually share the dependencies. It will only download once, and so the second request would automatically hit the HTTP cache. Sean Larkin said that in Webpack 5, they would have the infrastructure to change that. They won't necessarily have it fixed with the initial release of Webpack 5. I'm hoping they will. I have an issue open from a year ago where I talked about exactly this problem, but I don't know any updates on where this is at. So just to be clear, you can use workers, you can use them with rollup, you can use them with parcel, which actually has built-in good support. So hats off to them. And you can use it with Webpack as well. There is just a slight caveat that with Webpack, you need to keep an eye on your bundle size because deduplication won't happen.
Yeah, this is like the third episode I've been on where people were talking about how good rollup is, and I haven't used it yet. And I keep saying I'm going to use it.
I really like rollup 4 because you actually it makes you write code instead of config. So Jake Archibald and I gave a talk at the Jamstack Conf how we built our build system for procs, and we used rollup after having used Webpack and Squoosh, mostly to get the feeling for how different it is. And what we really liked is that we were in full control when we wanted to be in full control. So we actually wrote, I think, like 16 plugins ourselves, like tiny one-off plugins that are so simple that everybody in our team was comfortable adjusting them to their needs. And I think that's a really interesting approach to build systems, rather than having a massive config file where you have to learn the quirks of all the plugins that are out there in the Webpack ecosystem. With Rollup, we felt like if we didn't find the plugin we liked immediately, we would just write one ourselves because it was very little friction, and we mostly want to like add a HTML tag here or remove an export there. Webpack can probably do all these things as well, but just to this day, I am not comfortable using Webpack. I don't understand the details on how it works.
Yeah, we had a whole
like
episode on it the last episode. I think we did.
Yeah, all about just talking about build tools. It sounds like grunt versus gulp, honestly. The way that you're describing it from back in the day.
No, it is very similar in that sense. Like grunt was weird, and and like you had. I think if I remember with grunt, you ended up creating multiple temporary directories to get like the individual build steps in there. I mean, gulp was better in that you had like the really nice streaming. You still had sometimes the need for directories, but you felt like, oh, it's just files passing through, and if I want to do something, I can just write a one-off little mini transform in the middle. So yeah, you're right, it is very similar. The only thing I dislike about the build system world currently in general is that every build tool is, again, in this case, the center of your build system universe, and every build tool wants to foster their own plugin ecosystem. It is very frustrating sometimes for me, but I think we're getting there. It's just going to take a couple more years.
Yep.
Middleware is death.
Yeah, I mean, I think we agreed last time too, Danny, that most of our time is spent fighting with the tools, right? And the coding after.
Some of them.
Yeah. So I have one more question, if you don't mind. So what's next for this adventure off the main thread? Like, do you have new experiments? Is Comlinks going to be moved out of labs? Like, what do you want to do with it?
That's it. So the next step is for me to finish preparing my talk at Chrome Dev Summit and give it. Where I'm going to talk about exactly this topic. Interesting that you say moving it out of Google Chrome Labs, because it was always supposed to be that you start experimenting in labs and then it graduates to Google Chrome. But now Google Chrome Labs has kind of become a brand of its own without any of our intentional push into that direction. So I actually didn't have concrete plans to move it out of there, but I think maybe I should. It seems like also a nice symbolism, like it is mature, you can use it now, kind of thing. So I actually like that idea.
You already have production releases on there. It looks like it's just that
the
word labs like would insinuate to someone that maybe I shouldn't use this in my production stuff.
Yeah, that's fair.
That's the only thing I would think of.
In other respects, really what comes next is like, I'm going to keep maintaining Comlink. I want to make sure it keeps working. I want to make sure that you can use it with the popular build systems. And then I really want to figure out how to make it mainstream, how to make not necessarily Comlink, but how I make workers like a standard, like an expectation for web developers. Something that is completely normal and even expected to be used in any web app. I think Comlink is going to be a big puzzle piece, but I don't want to give the impression that it has to be Comlink. If a better library comes along, then I'm super happy that someone wrote something that is actually better. But I think I'm mostly looking into really figuring out what is keeping people from using workers, what is Comlink not giving them that they need, and what other tooling is required to actually make it easier so that the running stuff on the main hood is the exception, not the other way around.
And you're getting me all psyched for Chrome Dev Summit. I'm gonna be like, listen, I'm like streaming it
Tune
right
in.
away now.
All right. Well, so we are just about out of time. This is one of my favorite topics in web currently. I was while we were talking, I was looking back at some of my old experiments. They're from like 5 years ago. It's like this stuff has been around forever, and
You're
I'm
ahead of your time, man.
I guess, or something. But this is it's I think it is a fascinating topic, and I think it is a shame that it is not that people don't use it, because people don't use things that they don't find useful, but that the story around it is not better, which is why I'm very excited for a lot of the work that you are doing, Surma, to make this something that is an expectation, something that's like, oh, this is just how I solve this problem, because it can be really helpful. And it's just cool. It's really cool. It makes you feel like a quote unquote real developer sometimes, because you're like, I'm spinning up operating system threads. Look at me go.
It really is cool. I love it, and the blog posts were really well written, easy to follow. So I thank you for that.
Also, for the audio listeners, real developer was in air quotes. I want to make sure that that's clear. All right, but Surma, thank you. Thank you very much. Do you have any last parting words before we bid adieu?
Oh, man, we didn't even talk about WebAssembly, which brings real threads to the web, but that's a different story. No, thanks very much for. I know, right? Thanks very much for having me and inviting me. And if you're interested, I'm just going to cheekily assume that we can link to my blog posts in the description. And if you want to know more, tune in at Chrome Dev Summit or hit me up on Twitter. Or if you're at Chrome Dev Summit, come and talk to me. I'm happy to chat for hours about this topic.
At least 1 hour.
At least, at the very least. So yeah, with that, I'm hoping I wasn't too waffly, and there was actually some coherence in here.
There's also some really good stuff you do with Jake on HTTP 203 or whatever, the podcast you guys do together.
Oh, promoting a rival
Yeah.
podcast. That's old move.
I'm all about the people.
All right, Surma. Well, thank you again. Eric, as always, it's a pleasure. It's a pleasure to talk. And for everybody that's tuned in, thank you very much for listening. This has been episode 194 off of the main thread.